This is CS50, and this is the end of week 1. So I'd like to introduce my former advisee, Ansel Duff, who not only makes iPhone 5 stands as well as this lectern, he also makes cars.
How's it going, everybody? I just want to tell you a little bit about Formula SAE, which I'm the captain. It's an MIT team. I just want to tell you guys a little bit about it and hopefully generate some interest. So let me just run through a couple things about our team. So we're completely student-run, wherein all of the members design, simulate, test, and manufacture a subsystem of the car. We have our own machine shop and garage in N51, which is the same building as the MIT Science Museum. And we are the people that drive the car. There's a national competition at the beginning of the summer, and then there are smaller shootout competitions throughout the year. And then we do driver training days to get new members acquainted. Our build days are on Saturdays from 11 a.m. to 8 p.m. Lunch and dinner are taken care of from Bertucci's and Beantown, respectively. We have a weekly meeting and seminar, which is for course credit, which is new as of this semester, and it will also be for next semester, so you can cross-reg for that. And then we have designing shop and CAD days during the week, where members will independently CAD parts, order stock, etc. So for electrical engineering at the team, we have our Tractive high-voltage system, which runs at a nominal 300 volts, which includes motors, motor controllers, and battery packs. Then we have a low-voltage system, which runs at 12 volts, which includes controls, CAN nodes, the brain box, and the dashboard. As far as CS goes, we do have website maintenance that we need done for events, membership changes, new pictures, and PR material. And then we have code that controls the car for our traction control, launch control, dash control, torque vectoring, and regenerative braking systems, which run typically in MATLAB, Simulink, and LabVIEW. Tell you a little bit about the car. So it's about 500 pounds. It's rules limited to 85 kilowatts. It has 2 MRAX 207 motors in the back, one for each rear wheel. It has custom-built battery packs from Prismatic A123 pouch cells, totaling 300 volts and 5.6 kilowatt hours. And it's direct drive with a 2.64 to 1 drive ratio. Here are some pictures we took of it at competition. Here's the back, the nose cone. And here are the motors, those big black discs underneath the Menzit Manus. Here's a slide that I pulled out of our competition scheme, and this is just comparing our car to a couple commercially available cars like the KTM Crossbow, Ariel Atom, and Caterham M7280. If you're familiar with price, power per weight, dollars per horsepower, and dollars per torque, and our car blows them all out of the water. If you have any questions, jot down this email address. Shoot us an email at fsae@mit.edu. We're happy to talk about anything that you'd like. Harvard students are kind of the minority on the team. If you have any questions about that, please do shoot us an email. Happy to talk, and I'm going to hand it back over to David. Thanks. Appreciate it, guys.
Ansel spent the summer working with us here on campus in CS50 this summer, and in addition to working on things like the binary bulbs, he actually really opened our eyes, and mine in particular, to what really the intersection of hardware and software can be. In fact, a lot of the things he just toured you through are ultimately created first in software and then ultimately fabricated in the real world in hardware. So if you're interested in exploring that intersection, perhaps take up that group. Now, meanwhile, those of you who are fans of technology and Apple products in particular know that there were a couple of announcements yesterday, but we thought we'd show you one that came out a few days prior that you might not have seen.
You know, once in a while, something comes along that changes the way we live. A device so simple and intuitive, using it feels almost familiar. Introducing the 2015 IKEA catalog. It's not a digital book or an e-book. It's a book. The first thing to note is no cables, not even a power cable. The 2015 IKEA catalog comes fully charged, and the battery life is eternal. The interface is 7.5 by 8 inches, but can expand to 15 by 8 inches. The navigation is based on tactile touch technology that you can actually feel. Content comes pre-installed via 328 high-definition pages of inspiring home furnishing ideas. To start browsing, simply touch and drag. Right to left to move forwards. Left to right to move backwards. Notice something else? That's right, no lag. Each crystal clear page loads instantaneously, no matter how fast you scroll. If you want to get a quick overview, just hold it in the palm of your hand and using just your thumb, speed browse the content. If you find something you want to save for later, you can simply bookmark it. And even if you close the application, you can easily find the bookmark again. Amazing.
So So that brings us to the end of week one. A few announcements now. So sectioning is now in progress. Go to this URL here sometime between now and Friday at noon to actually specify whether you are among those less comfortable, more comfortable, or somewhere in between. This is typically one of those things that you just kind of know. And in fact, those of you who are less comfortable probably know as much. Those of you who are more comfortable know as much. And again, if you aren't quite sure which of those buckets you fall into, you're probably somewhere in between. But rest assured, you can swap after a couple of weeks if need be. Meanwhile, for the coming week, we don't start sections per se, but super sections, which are open to all students this coming Sunday at a location to be announced on the course website. We will have one for those less comfortable, as well as one for those more comfortable, and those somewhere in between can choose which of those two or both if you'd like to sit in on. And the focus of those will be ultimately on C, which we'll continue our conversation of today. Problem Set 0, meanwhile, is hopefully in your hands, officially due tomorrow, Thursday at noon, unless you cash in one of your 5 late days, which would bring it until Friday at noon. Problem Set 1, meanwhile, will be posted on the course's website, and this will be our first foray as a class into C. And that problem set spec will walk you through a lot of the mechanics of what we started talking about on Monday and we'll continue talking about today. C, Linux, the CS50 appliance, all of that will await you in the specification. Office hours, meanwhile, are in progress in undergraduate dining halls. Head to this URL here to see the schedule for tonight and tomorrow if you would like to partake. Questions, meanwhile, so that you have opportunities to ask questions asynchronously 24/7. Realize you're not limited to sections and office hours, but rather this tool here, CS50 Discuss, at that URL, will be the course's online bulletin board software via which you can ask questions of classmates and also staff. So keep in mind that resource as well. Meanwhile, a tradition starts this Friday. As you may have glimpsed from last Wednesday's teaser video, we have a tradition most every Friday during term of taking some 50 students and staff to a local restaurant called Fire and Ice, at which we're typically joined by some alumni or friends from industry to generally aspire to make a large class feel smaller. So it's a completely casual lunch. A bunch of us, the staff especially, will play musical chairs and chat with students about 50, life outside of 50, life in the future, the real world. I'm talking about job opportunities with friends in industry. So if you would like to join us this Friday, head to this URL here. Space is limited, but we'll do this recurringly throughout the term. Head there to cs50.harvard.edu/RSVP. And if you don't get in this time, not to worry, we will do it again in the coming weeks as well. So, this is the picture we painted last week, and you've probably been dabbling in thus far, but let's try to connect this now to what we're going to do today and onward. Could I have one volunteer? All right, or several. How about here on the end, in the blue shirt? Come on up. What's your name? Alana. So Alana, for just a moment, nice to meet you, is going to play the role of this function here. The purple block we've called thus far a function. So what I'm going to go ahead here and offer Alana is a little name tag to make clear what role you're playing. So you shall be the say block, if you want to go ahead and put that on. And we're going to keep this super simple. If the goal at hand is simply now to implement with Alana this so-called say block, here's how it's going to work. I have, let's call it an argument or parameter. It's really just a blank sheet of paper, and it's white to kind of be reminiscent of the white box into which you can write words. Meanwhile, I'm going to go here. I'm going to go ahead and write HELLO, comma, world. And now I, as say the programmer, don't actually know how to say something. I can come up with the words, but I don't necessarily know how to express myself verbally or on the screen. And so what I'm going to do is take this piece of functionality whose input, or argument as we'll call it, I've written on this piece of paper, and I'm going to outsource it. And indeed, that's the role that functions in a programming language can play. Something like the say block can be outsourced to someone who really knows what she or he is talking about. So if we'll step over here for just a moment, I am going to pass this input to Alana and ask that you say this input. That's it. So that there is a function. Now we can take it a little more we can take a step forward here, because that was clearly underwhelming. So let's now convert this to something a little more sophisticated. So this, of course, is our C version. So now if you want to take that one off, that name tag off, and let's have you put on a new name, but fundamentally you're playing the same role. It just so happens to be called printf now. The story is, of course, going to be probably just as underwhelming, is going to be the following. You are now the function printf. I am the caller, or the programmer, who wants to stand on the shoulders of people in the past, like you, who've already figured out how to actually write something down. And so this time, rather than say it, let's actually use our screen over here. So if you'd like to step over here, I'm going to pass again this as input to my printf friend. If you could go ahead and print that on the screen simply by drawing with your finger on the black screen. Excellent. All right, so lots of suspense for how that was going to play out. So now let's take things up one final notch, if we could, as follows. So this is a C program, as we said last time, and this just does what you did. It prints out to the screen, hello world, even though there's clearly a lot of distracting stuff up there. But let's take things up a notch and introduce this version, which recall was the third version that we ended up with last time. And now there's clearly two uses of printf. There's two calls to Alana, in this case for printf, but there's also a call to another function. What's that function clearly? GetString. Can we get one more volunteer? Okay, come on up. What's your name? Javier, come on up. So Javier's role is on this piece of paper, which I'm going to call generically S. Now, this is a variable. It's of type string, as implied by that second line in the middle there. And I'd like you to go get me a string. Specifically, head down to the orchestra section and get me the name of someone and come back with a variable containing that value. It can be anyone you want. Here we go. All right, Javier is writing down the name. All right. We can all probably guess how this is going to play out. We're perhaps belaboring the point of what a function is doing, but nonetheless, thank you very much. So Javier has returned this string here, which, can't quite see, is Jonathan is the string that we've gotten. So now what I'm actually going to provide to Alana, though, is something a little different. Because in this version of the program, first there's state your name. So the very first argument I need to provide Alana with is going to be literally state your name. All right, so simple as that. I would hand this to you, and as I write up the next argument, if you want to go ahead and write this on the board, let's go ahead and do the final example here to make clear what's ultimately got to happen. So state your name, write it toward the top if you don't mind, just so that we have room for one second line, because the last thing I'm going to now provide you with is not one, but two pieces of paper. All right, so H-E-L-L-O, comma, and then a blank line. So what I'm about to hand Alana now is something a little different. Not only is she getting this, where fill in the blank represents that percent, what was the placeholder we've been using? Yeah, so percent %S. And meanwhile, I'm going to pass her in a second argument, which is precisely what Javier retrieved from Jonathan. So let me give you these two. And if you'd like to go ahead, print that effect. What's ultimately happening now is Alana, again, is playing the role of printf. Javier was playing the role of getString. So that will be your souvenir. And ultimately, what's happening, despite this hello, yep, go ahead and comma. Yep, you've received them both at once. So the idea is that you can now flip the page to handle the second of those two inputs. So this is only to hammer home the point that whereas Alana first executed this green line here, then Javier did this one for us and returned to me something we'll call S, but it was really just that piece of paper of his own. And now Alana has done this third line. And even though all of this, thank you, looks so incredibly cryptic perhaps at first glance, it really is as simple as that. Passing inputs around, getting outputs, either being physically handed back something or seeing a side effect like this, something visually written on the screen. So let's go ahead and thank Alana and Javier was down here for joining us up here. All right. So now let's take for granted just how straightforward all of that might be, and let's proceed to actually do something in actual code. So up on the screen here is a screenshot of that so-called CS50 appliance. And if you had to, as of 2 p.m. on Wednesday afternoon, explain to some friend what the CS50 appliance is, how would you define it in a sentence? Any one sentence. Yeah.
It's like a program that makes everyone's computer run with the same system.
Good. It's a program that enables everyone's computer to run with the same system. It's sort of your own copy of an operating system that happens to be called Ubuntu Linux, and it runs effectively inside of a window on your own Mac or PC, so that this way, right out of the gate in week one, everyone here in the class has access to the same tools, the same configuration, and there's no learning curve specific to a Mac or a PC in particular. Now, we opened up inside of the CS50 appliance on Monday this program here. Happens to be called gedit, but that's really just a graphical editor. It's something like Notepad or TextEdit on Windows or Mac OS, respectively. And I proposed that there were really three important parts to this screen. The top side is where you would write your code, and that's where we spent much of our three examples in Monday's lecture. The bottom we called what? This black window. Yeah. Compiler we accessed by way of that window, but more generally, yeah, it was just a terminal window. This is an age-old term that just describes essentially a blinking prompt that years ago used to be on one of those big CRT-style monitors, but nowadays it's sort of virtual in software. And the terminal windows lets us type commands. It's sort of the simplified version of a user interface, or UI. It's not a graphical user interface or GUI. It's a text-based interface or a command line interface. And indeed, that's where ultimately I was able to write some code. Once I had written some code, though, recall that I used this command. And as the name kind of suggests, this allows me to make a program called hello. But what was it really doing? Well, make was taking my input, my source code, and converting it to what ultimately? Object code. And object code is just a fancy way of saying zeros and ones. And then once I wanted to run that object code, once I wanted to pass as input those zeros and ones into my computer's brain, the so-called CPU, or central processing unit, I had to run the program, but it wasn't quite as simple on Monday as just double-clicking some icon. What instead did I have to do in order to run a program? What was that second command? I'm hearing a little slashes. Yes? Yeah? Exactly. / and the program's name. Now, what did this mean? Well, dot is just an arcane way of saying current directory. Whatever folder you are in is represented as dot. The slash is just what you've seen in Mac OS and Windows for years. It's a separator between a directory or folder and the rest of some name. In Windows, it happens to go backwards. In Linux and Mac OS, it happens to go forwards. But it's just a separator, so it's just an uninteresting syntactic detail. The juicy part, of course, is the name of the program, hello, and that's what make created for us. It outputted that file for us. But how did we get to that point? Let's now ask the question, what was really going on here, at least with regard to some of this syntax? So in a sentence or so, how did we explain away this first line that's highlighted in green? What was that first line doing with respect to my program? Yeah? Say it again?
Including and downloading past functions.
Good. Including, or I won't say downloading, but let's say including functions that people have written in the past. And those functions are implemented somewhere in my computer. Someone wrote a file years ago, and that file's somewhere inside of the CS50 appliance or on my hard drive more generally. And so this line is essentially saying, go find that file, standardIO.h, and copy and paste its contents right here on the top of my file, so that I don't have to do that manually myself. And among the juiciest pieces inside of that file we claimed was what function? What function did we say was declared or mentioned in standardIO.h most likely? Printf, right? We did not write printf on Monday. It just existed. Much like Alana came up on stage and she just existed and knew how to draw something on the screen, so does printf exist for many years, and so this is how we access it. Now, if we move on here, main was analogous, we said, to the puzzle piece called when green flag clicked in the world of Scratch. It's just sort of the default name that humans decided would represent the default entry point to a program, the chunk of programming code that gets executed first. Meanwhile, these curly braces are kind of like the curved shape of a lot of those yellow Scratch pieces that kind of encapsulates a whole bunch of instructions together. So it just kind of binds together some related functionality. Printf, of course, is a function that prints to the screen, as we just did. What about these parentheses? How would you define, even if you've never programmed before, but just based now on an increasing, hopefully, intuition, what are the parentheses doing for us here? Or what are they surrounding? Yeah? Yeah, they're saying what you're going to print with printf. Or more generally, they are surrounding the inputs to the function. So you can almost think of those parentheses as being like the metal clip on this clipboard. It's what's going to be used to provide arguments into the function, which in this case is called printf. So in general, almost any time we call a function, we are going to see a pair of parentheses, maybe with something in it, like now, maybe nothing in it, but that's where you would put the inputs or so-called arguments to a function. Here's one such argument. I've highlighted everything between the quotes because it turns out in this language called C, when you want to represent a string, that is a word or a phrase or even a paragraph, you have to surround it with double quotes. Not single quotes, double quotes. And that's exactly what I've done here. Meanwhile, there's a funky symbol toward the end there, the \n. What did we say that represented? Yeah. New line. Right? You don't generally hit enter when you want the program to spit out a new line. Rather, you tell it explicitly with this admittedly arcane piece of syntax, \n, that you want a new line to go there. Finally, the semicolon. We didn't really talk too much about this, and by far this will be the bane of some of your existence for the first problem set when you just fail to realize you've forgotten something as stupid as a semicolon, and generally putting it there will fix that problem. But what's it doing for us, would you say? Sorry? Finishing a statement. It's sort of like the period at the end of an English sentence, whereas in this language C, it's ending a statement, an instruction of programming code that you just want to say, I'm done with this. Now notice that's the only one here, so you don't want to get in the habit of putting semicolons after every closed parenthesis. For instance, there's none next to void, and we'll come back in the future to what void means. But in this case here, printf is a function or a statement being used, and so we want to have that terminus at the very end of it. And I'm intentionally picking on C. And frankly, a lot of languages like C, C++, Java, JavaScript, and any number of other languages have a lot of these sort of syntactic details that certainly, if you're new to programming, can genuinely trip you up. And you will, mark my words, some of you, have this experience in office hours or late at night working on some PSET where your damn program just doesn't compile, it doesn't run, you have no idea what's wrong, it seems completely logically correct to you. It's because you forgot something like hitting a semicolon at the end of some line. But these are the kinds of things you're going to immediately learn to see. And indeed, these are the things that the CAs and TFs have been sort of trained to see much more quickly than you. And so this is only to say, as you dive into problem set 1 especially, don't get frustrated by this stuff. Once you sort of acclimate to the world, you begin to see things that you might not see at first glance this first week. So source code is something like that. We want to pass it into the so-called compiler. And that compiler, as we said, provides output known as object code, the so-called zeros and ones. But from there, what does that give us? Well, it gives us these patterns. And again, your computer, your Intel inside, understands these patterns of zeros and ones. And sometimes the pattern represents an actual decimal number, as we saw last week. Sometimes it represents a letter, like we saw last week. Sometimes it represents an instruction, like printing something to the screen. So printf, for instance, let me rewind. We've been taking for granted that those zeros and ones are produced by this command make. But make is not a compiler. Make is not the thing in the middle that's producing the zeros and ones. Rather, make is just a very conveniently named program whose purpose in life is essentially to figure out how to compile your program. And we use it in these first weeks because it just saves us a lot of trouble. But what make is really doing when you compile hello is, as we said last time, it's looking on your hard drive or in the current folder for a file called what, apparently? Hello.c. Right? That's just kind of a convention. It's arbitrary, but that's the way things are. Make, if you just specify the name of a program that doesn't yet exist, it's going to look for the source code in a file by default named hello.c, and if it finds it, great. It's going to convert that source code into object code for you. But every time I've hit enter after running make hello, do you recall seeing last time a fairly long and cryptic sequence of other white letters and characters on the screen? Well, that was the actual command, the actual compiler that was running. So the actual compiler we'll use most of the semester is something called Clang. Some of you might have used Visual Studio before, or GCC, or any number of other compilers. We'll use Clang, and Clang allows us to actually convert that source code to object code. What does this actually mean in practice? Well, let me go into one of my folders from last time inside of the CS50 appliance, and let me go ahead and create this same file. Include standardio.h, int main void, and we'll come back in the future as to what int means and what void means. But for now, let's do hello world \n, just like we did on the board. Let me save this file called hello.c. And now, if I want to compile this, I could, let me zoom in, run make hello, enter. And this, again, was that very cryptic line. But now at least one word probably jumps out at you. Clang is that line we saw before. Now, there's a lot of other stuff, frankly, that we'll wave our hands at for today. But there's a few a few characters in here that are of interest. But I'm going to go ahead and do this. I'm going to first run hello just to prove that this is working as it was Monday. But now I'm going to delete the program. And much like we had these short names last time, the command for removing something is rm, remove, enter. You're going to get some fairly cryptic questions. It's hard to believe that you can make even this question hard to understand. But remove regular file hello just means do you want to delete hello? And I can go ahead and type Y for yes, enter, and now it's gone. What this means now, if I clear my screen, is that instead of doing make hello, you know what, I'm getting good at this. I'm going to run the compiler myself. I don't need some program to figure out what my file is called. I wrote hello.c. I know what it's called. I'm clearly capable of typing that. So I'm going to go ahead and do clang hello.c. Enter. Seems to work. And there's no additional output because clang is the compiler. It's what's converting the source code to zeros and ones. So if I now do /hello, enter, new error message today. So bash is just the name of the blinking prompt that we're using. That's a gross oversimplification, but for now that's all that is. It's the blinking prompt, and that's why it's yelling at us. No such file or directory is a little more straightforward, but surely I made that object code. But the catch is that if I type the command to list the contents of this directory, which is what? ls for list, there's a bunch of stuff in here, some of which came with the appliance, like my desktop folder, downloads folder, Dropbox folder, and all that stuff. But what is interesting is hello.c, which I created a moment ago with gedit. And what's the weirdest looking name in here, perhaps, that we didn't see last time at all? a.out. Right? So back in the day, it was just decided that when you compile a program for the first time, and you don't specify the name of a file, let's call it A. And a.out just means this was the output of the compiler. So it's a horrible name for a program, but by that logic, / for current directory / a.out should mean there's, in fact, my hello world program. Now, a little warm-up exercise, too. If I want to rename this file, turns out that you move a file from one name to another. So mv a.out, and then I can call it hello, enter. So this is a Linux command. DOS had this years ago. Windows has a terminal window of some sort that looks like this. Linux and Mac computers have this blinking prompt, even though most of us probably rarely, if ever, use it. But what I've done is run a program whose name is mv, and I've provided it with two arguments, so to speak, two inputs. A.out is the original name. Hello is the new name. So if I now do /hello, enter, that exists. And if I do /a.out, what do you expect I should see? Bash, no such file or directory, because I just renamed it. So this takes a bit of getting used to, but the problem set 1 specification will truly hold your hand through some of this minutia, because this is a complete intellectual distraction from the more interesting ideas at hand, which is actually creating something out of code. But let's do one modification now to this program. Recall that last time I did something like this, printf, state your name, and indeed we just did this on the big screen over there, and then I did string s gets get string, open paren, close paren, and paren just shorthand notation for parenthesis. So does getString take any arguments? No inputs? No, but it needs the parentheses because that's what demarcates the calling of a function. So I'm going to go ahead and try to run the compiler on this program now, clang hello.c, because I didn't change its name for now. And I got a bunch of errors. Let's zoom out here. If I scroll up again, like I said last time, to the first, same error that I got last time. On line 6 of hello.c, I had an undeclared identifier string. Did I mean standard in? I didn't, because what mistake have I made in this program, if you recall from last time? Yeah. Yeah, we need the so-called training wheels that we'll just use for a few weeks, but I need to specify that also somewhere inside of the appliance is a file that we wrote just a few years ago, inside of which are functions like, apparently, getString. So now if I go back down here, zoom in, and rerun clang hello.c, oh, damn, another error. But we haven't seen this one before. This one's a little more esoteric to figure out. But this is deliberately on the screen because we wanted to tell this story. When you compile hello.c just as the picture from before suggested. You're only converting that source code to zeros and ones. Now, CS50 staff a few years ago wrote CS50.h and a corresponding file, CS50.c, and we, a few years ago, compiled those files into a file that happens to be called CS50.o, or it can be renamed a few different things. But that's a simple way of thinking about it. So we compiled CS50's library into zeros and ones. But nowhere have I specified that I want to combine my zeros and ones from my Hello World program with the zeros and ones that CS50 staff created a few years ago into one complete program. All I've specified by writing clang hello.c is compile hello.c. I've not told clang to link in the zeros and ones that CS50 staff created for you some time ago. So it's an easy fix. -L for link CS50. And we'll again see this before long again and again, but notice now there was no complaint. So now if I run /hello, now it's working. Although that's a bit misleading since I just recreated what file? a.out. So let me rewind for just a moment. The program we just compiled has these 3 lines of code. When I ran hello a moment ago, I didn't see state your name, and that's because I ran the old version of the program. But if I do indeed run /a.out, enter, state your name, Rob, hello world. That's kind of a bug. Probably meant to say Rob, right? So what's the fix here in code? Yeah, in back. Exactly. So I just need to make that final tweak so that I'm passing in a placeholder, like a fill in the blank, like we did a moment ago, but %s is now that fill in the blank. So lastly, let's reveal one last detail so that there's no magic. I'm going to go ahead and get rid of hello. I'm going to go ahead and get rid of a.out, so now I have no programs, just my source code. And I'm going to run a slightly longer command, clang -o hello, hello.c-l CS50. Now this is starting to sort of go in one ear and out the other perhaps, but just tease apart what this is doing. Clang is the compiler. -l CS50 deliberately at the very end does what in a sentence? Links to the CS50 library, grabs the zeros and ones that the staff made and crams them into my own program. So the last question at hand is, what is -o hello probably doing, even if you've never seen this syntax before? Outputting a program that's not named the default a.out, rather it's named hello. So now there is no a.out, no such file or directory, because I have explicitly said call this program hello so that I can now type in a name like that and have it behave. Now, frankly, boy, is that uninteresting to have to remember all of that little minutia, right? So let's go ahead and get rid of hello again, and let's now return to a world in which it suffices to say make hello. But that's the magic that make is doing for you. That's the tedium that it's doing for you. And as our programs and problem sets get more complex, make will truly be your friend, because not too long from now, we're going to have programs that are written not with one file, but several files, and make will automate the process of compiling all of that for us together. So now, printf. Printf is inside of this file, standardIO.h, that we've seen before, but there's more to printf than that. There's \n, but there's also a bunch of other escape sequences. An escape sequence is just a fancy way of saying something that starts with a \, not a /, a \, and does some special thing. And we won't dwell on most of these, but why is there \double quote, do you think? Why is there this weird sequence of characters, \double quote? Why might that be useful? Exactly, right? Think back to our Hello World program that we've seen quite a few times now. Every time we've seen that Hello World program, we've had double quotes inside of which is hello, world, \n. But think to yourself, what if you actually wanted to print out a quotation mark? If your first instinct might be, and I don't know why I might want to do, or here, we can be a little passive aggressive. Hello, friend. We might want to do something like that. But why is this now problematic? Ignoring the curly quotes aside that Keynote made for us automatically. Why is this problematic?
Because the second quotation, the quotations after friend would connect to the first quotation before hello.
Exactly, because we have like 4 quotation marks. Well, the first one probably goes with the second one, and maybe the fourth one goes with the third one, or, I mean, I'm not even sure, nor is the computer going to be. Computers, again, compilers, again, are fairly dumb. They'll only do what you tell them to do, and if you're not unambiguous, they are probably going to throw an error. If you're not unambiguous as to how to make a peanut butter and jelly sandwich, strange things might arise. It's the same idea. Now, suffice it to say, there's some other escape sequences, but we'll come to those before long. Essentially, these escape sequences represent something that you might not be able to type too easily at the keyboard without confusing the computer. Now, meanwhile, we have placeholders in printf. %d, which can also be written in almost all cases as %i, is a placeholder for what type of data, what type of value? A decimal number. So, and you can actually, we'll start using %i because it's a little simpler, like an integer. %i in integer that happens to be decimal. %s, we already said, was a placeholder for a string, which is just a word, a phrase, a paragraph, an essay, whatever. It's a sequence of characters of some length. And we'll see before long some of these others, but %c is for a single character. %f is for a floating point number, like a real number that has a decimal point in it, which is, of course, not an integer. And there's a whole bunch of others as well. Meanwhile, in C and in a lot of languages, we have different data types, different types of glass bowls, if you will. The bowl I used last time was for ping pong bowls, but we can also store different values like chars and strings and integers in a container, like a variable. And C has these. Char is the type of data, the type of variable in which you can store a character. Float is a type of variable in which you can store a real number. Int is, of course, for an int, and rather ridiculously named, a long is where you can store essentially a really long number with even more digits than a typical int might store. But we'll come back to that before long. In CS50.h, meanwhile, the other header file that we've seen a couple times in use, there's 2 other data types that don't exist in C typically. One is string, and we'll see in a few weeks what strings really are underneath the hood, and one is bool. And a bool is a variable that can only take on certain values. And just based on last week's explanation of Scratch and more recently C, what would you guess are the 2 possible values for some container that is of type bool? Yeah. Yes and no, 1 and 0, true or false. And indeed, it's the last that tends to be conventional in a programming language, saying something like true or false. Meanwhile, the CS50 library comes with a bunch of functionality that the staff wrote for you besides just getting a string. We wrote in advance functions that can get an integer from the user, get a single character, get a float, that is a number with a decimal point, get a long, like a really big value from the user. So we've only seen this in action in the form of getString, but via these functions will you soon be able to write programs that get input from a user. Meanwhile, consider this program and consider how we might now start to add to it with new constructs. A quick whirlwind tour, and then we'll look at writing some programs manually ourselves. Henceforth, if we want to implement a condition, it's not going to look like a nice little pretty puzzle piece. It's going to look a little more arcane, but this is the canonical structure of a condition in C. The word if, 2 parentheses, inside of which is going to be some kind of Boolean expression. Now the / in the middle, this is at the moment sort of like pseudocode placeholder, but more properly, any line of code in C that starts with / is a comment. It's like a sticky note that you might put on an essay printed on paper. It's a note to yourself. It has no functional impact on the program. It's sort of a reminder. It's your own documentation as to what's going on. So do this at the moment is sort of a placeholder for whatever's inside of those curly braces eventually is going to do something. Meanwhile, you can have 2 forks in the road, an if-else construct like this. You can have if, else. Now, it's worth noting, especially if you've been Googling around online for resources out of curiosity, or if you pick up one of the course's recommended books on C, you will see that humans have lots of different preferences for how to express themselves in code. Some people like to put the curly braces, as I've done here. Some people like to put the curly braces, for instance, up here. Some people like to put the else's up here and then this over here. There's any number of ways to write code, and none of them are right per se, though there's a few that are pretty wrong. But this is ultimately a very religious debate. In fact, one of the most annoying things about computer science is how opinionated computer scientists can be. And you will find over time that even you develop personal preferences as to how your code should look, not just behave, not just create output, but how it should look aesthetically. So what we will do is guide you along the way toward, for now, at least a standard CS50 style that at least keeps things uniform and easy to read. But more on those distinctions before long. A Boolean expression in C, if you wanted to say if this condition is true and this other condition is true, you don't write the word and as you would in English. You instead use ampersand, ampersand, for reasons we'll come back to. If you want to say or, you use two vertical bars, which on a US keyboard is generally above the Enter key, next to the backslash. And this just means if this condition or this other condition is true, do this. Meanwhile, there's this crazy thing, which you'll have occasion to use once in a while, but it's just an alternative way to express yourself. This, for now, let's stipulate, is just another funky way of expressing if, else if, else if, else if, else if. It's just formatted in terms of cases, where you literally enumerate the values that you might want to check for. Meanwhile, loops. We saw a comparison of Scratch with a loop, and I'm going to wave my hand at what each of these things means, but notice that a loop will very often start with the keyword for, or it will start with the keyword while, or it will start with the keyword do and end with the keyword while. But what we're about to see is things more like this. Here's in general in C how you might declare a variable and give it a value. In C, it doesn't suffice like in Scratch to just say, give me a variable called something. You have to tell C, and tell your compiler more specifically, what type of value do you want to put in the glass bowl? Is it an integer? If so, you have to literally say int, and then the name of the variable, then a semicolon. If you instead wanted string and called it s, like I did in my code here today, you would say string, s, semicolon. Once you want to give it a value, you can then use the equal sign, otherwise known as the assignment operator. And notice how each of these lines of code has a semicolon at the end of it. But frankly, this just looks a little ugly. Why can't I say to the computer, give me a variable and initialize it to 0? That is, give me an empty glass bowl. Well, you can. And so one of the judgment calls you'll have to make stylistically over time is, do you write your code like this? Or do you kind of clean it up and impress people by writing 2 lines as just 1? And this would be considered generally a more elegant way of writing your code stylistically. Functions we've, of course, seen. They're going to take this format, the name of a function, some parentheses, and then maybe some stuff inside. Or you might see uses of multiple functions side by side, like something like this. Now, as a tangent, does this joke now make sense? Slightly. Doesn't mean it's funny, but it does perhaps make a little more sense. So now let's go into the CS50 appliance for a moment, and let me open up one teaser here. And indeed, one of the reasons for introducing the IKEA catalog and then flashing the picture of the iPhone a bit ago was to actually tie in together the fact that just a few years ago, in 2007, this piece of code was released, which was one of the very first implementation of a piece of software that does what's called jailbreaking. For those unfamiliar, jailbreaking something like a phone or an iPhone means essentially figuring out how to do things with it that the company who made it didn't intend. Like you want to install certain software that's not in the App Store, jailbreaking your phone lets you do things like that and more. But what was fun in 2007, and there's been dozens of different versions of these things since then in all sorts of languages, is that this program here called iUnlock was actually written in C. And so I pulled up the source code for this just to kind of show you some of the similarities with the constructs we've been discussing thus far. Now there's way more complexity here than we've seen already in class. Let me scroll up just a little bit here. But notice these, well, notice a few things, but notice these lines here, including standard.io.h. And a whole, line 24, please. Notice standard.io.h. And a whole bunch of other files that apparently other people have written. And if we scroll down through this, a little arbitrarily, notice, I don't know how to write all of this myself necessarily yet, but there's if. So apparently this has a branch. And if I scroll down a little further, there's another if. If I scroll up, I think around line 100, I saw, for. So I'm not quite sure how this works yet, but this is a for loop that's going to let me iterate some number of times. And if I scroll all the way to the bottom, I see that there's a function down here called main, and some additional credits for your reading pleasure. So this is only to say, and we'll put this online among the course's source code today, that even some of these devices that we take for granted, at the end of the day, are still using these basic constructs that we've been introducing already thus far. That's enough of that one. All right, so now let's actually build something. Let's go beyond something like hello.c and open up let's write this program here. I'm going to go ahead and write a program called adder.c, whose purpose in life is going to be like my first super simple calculator that just adds a couple of numbers, not because that's a hard problem, but because it allows me to now tie together a few things. So I'm going to go ahead and include standard io.h and cs50.h. I'm going to say int main void, and again in the future we'll come back to what int in this context and void means. And now I'm going to say something like printf, give me an integer. And now in my second line, how do I express myself such that I want to declare a variable that's going to store an int? Literally, what do I type if I want to create a variable that stores an int, would you say? Yeah? Int a equals get int. Sure. So that works. And just for consistency with the code you'll see online, let me change this to x, just because x is a common variable name to use at least in algebra. Now let me go ahead and do printf again. Give me another integer. And now I'm going to kind of learn from that pattern. I'm going to say int y gets get int. And we've not used get int before, but just like get string goes and gets a string like Javier did from the audience, similarly does get int start blinking the prompt and effectively waiting for the user to give it an integer by typing it in and hitting enter. Now lastly, I'm going to do this. Printf, the sum of, and let me get fancy now, %i and %i is %i, exclamation point, \n. And what do you think I'm going to put in now as the additional inputs to printf? I don't want to say literally quote unquote x. I want to pass in x, and now let's get fancy and let's just assume we can do what we want. What do you want to say next? X plus y. And indeed that will work. It's minimally programming languages do understand basic arithmetic, and so this should in fact work. So let me go ahead and do make adder in my black and white window down here, enter. Cryptic line, but no error message, so that's good. /adder, give me an integer 1, give me another integer 2, and the sum of 1 and 2 is 3. All right, so a pretty trivial program, but what's it done? It's allowed me to use a function call here, call another function here, 2 calls to get int, a third call to printf, and then using these placeholders. So it's a little more sophisticated than last time. Well, what if I want to get a little fancier? Let me go ahead and now do this. Let me go ahead and create a new file called conditions0, and I'm going to save some time for class's sake and just paste in that code as a starting point. And now I'm just going to put something new here in the middle. So printf, I'd like an integer, please. And all of this code is available on the course's website. You needn't type it all out in class if you'd rather not. Int, and now I'm going to use, instead of x and y, I'm going to use n, which is probably the most common name for an integer in a computer program. And now I want to do a little judgment here. I'm going to say if n is greater than 0, then I'm going to say printf, you picked a positive number, exclamation point \n, close that. Else, I'm going to print out printf, you picked a negative number. Now, before you yell at me, let's run this program. Let me go down here, and how do I compile a program called conditions-0? Make conditions-0. Kind of a stupid name, but damn it. Okay, good teaching moment. Why did that break? What did I accidentally call this file? You can kind of infer from the tab up here. So it's not bad that I did this, because this will happen perhaps to some of you. So I accidentally named my source code condition0. But my source code, by convention, should be in a file called condition0-c or whatever .c. So let me fix this. Just like Microsoft Word, I can go up to Save As and do condition0.c. Now, just to be tidy, I'm going to go ahead and remove condition0, which was my old version. And now let's do make condition0, enter. Okay, seems good. Condition0, enter. I'd like an integer, please, 50. You picked a positive number. Now, how about negative 50? You picked a negative number. How about now 0? Pretty sure 0 is not negative. So this is kind of a logical bug. How do I fix this? Else if n is less than 0, do this. Else, we can have a three-way branch here. Printf, you picked 0. So now if I rerun this program, after compiling it again with make, and now rerun condition0, what I'll see here is 0 gives me that output. So where are we going with this? Well, it's very easy to lose sight of the forest for the trees, and so allow us to conclude with this 2.5-minute video that ultimately is a bit of an ad from Google, but that really is testament to what even using these basic building blocks we can ultimately do once we have a bit of programming savvy under our belts.
It was 26 years ago, and I was just about to turn 5. We got to the train station and we boarded a train together. My brother just said, I'll stay here and I'll come back. And I just thought, well, I might as well just go to sleep and then just wake me up. And when I wake up the next day, the whole carriage was empty on a runaway train, a ghost train taking me I don't know where. I was adopted out to Australia to a Australian family, and Mum had decorated my room with the map of India, which she put next to my bedside. I woke up every morning seeing that map, and hence it sort of kept the memories alive. People would say, you're trying to find a needle in a haystack, so you never find it. I'd have flashes of the places that I used to go, the flashes of my family faces. There was the image of my mother sitting down with her legs crossed, just watching her cry. Life is just so hard. That was my treasure. When I was looking at Google Map, I realised there's Google Earth as well, a world where you could zoom into. I started to have all these thoughts and what possibilities that this could do for me. I said to myself, well, you've got all the photographic memories and landmarks where you're from and you know what the town looks like. This could be an application that you could use to find your way back. I thought, well, I'll put a dot on Calcutta train station in a radius line that, you should be searching around this area. I sort of came across these train tracks and I started following it, and I came to a train station which reflected the same image that was in my memories. Everything matched. I just thought, yep, I know where I'm going. I'm just going to let the map that I have in my head to lead me and take me back to my hometown. I came to the doorstep of the house that I was born and walked around about 15 metres around the corner. There was 3 ladies standing outside adjacent to each other, and the middle one stepped forward, and I just thought, this is your mother. She came forward, she hugged me, and we were there for about 5 minutes. She grabbed my hand and she took me to the house and got on the phone. She rang my sister and my brother to say that, your brother has just all of a sudden appeared like a ghost. And then the family was reunited again. Everything's all good. They helped my mother out. She doesn't have to be slaving away. She can live the rest of her life in peace. It was a needle in a haystack, but the needle was there. Everything's there. Everything we have in the world is the tap of a button, but you've got to have the will and the determination to wanting it.
Wonderfully sweet testimonial to just what you can now do with technology. We will see you next week.